All right, here we go. Let's look at how you did on section 1. Name the plane on top of the cube. So when we talk about the top, we're talking about this flat surface up here. And notice that there are several points, point A, point B, point I, point C, and point D. So a correct answer would be plane. And then you need to fill in 3 letters on the top of the plane. Now the 3 letters that you would not want to use are B, I, and C, because those are what we would call collinear points. They only tell us where that line is. And so we would want to use something like plane A, B, C, and it's important that those 3 points are not on the same line. So any 3 points other than B, I, and C would be great. That kind of answers number 2, name 3 collinear points. So B, I, and C would be collinear points. And you've only got one other option. You could have also pointed out E, J, or H. 3 non-collinear points, well, you've got lots to choose from. So I could pick any 3 points other than that. So I could say, for example, G, C, and A. Those are non-collinear points, right? So name all points, this should say points, coplanar with points A, B, and C. So we looked at that up above. We see that here's A, here's B, and here's C. We're talking about the top of the cube. So that leaves us with point D and point I. And then last of all, name any lines that pass through an edge of the cube at point D. So for the edge, I'm going to go ahead and erase this stuff. For edges, we're talking about where those 2 planes meet together. So this would be an edge, this would be an edge, these would all be edges. Edge, edge, all those edges. And we're talking about what would be the lines that pass through one of those edges at point D. So we're going to have several. We've got a line going through this edge, and that would be CD or DC. You could also name it. We've got this one is an edge passing through there, and that would be the line from A through D or D through A. And then we've got one more. I missed. But it'd be from D through H. So D, H. And of course, any of these could be written backwards because whether it starts at one point or goes through the other is not important. So that's our first section. So with that, we're ready for our last few vocabulary terms. So let's go back to our note sheet and we're going to finish this up. Okay, so we had coplanar, and so our last few terms, we're going to talk about part of the line that we would call a ray. So what is a ray? So this is a portion of the line that has an end point. So it does not extend forever in both directions, but only in one single direction. Okay? So this is a part of a line beyond an end point. So we're taking part of the line and all of the line that extends beyond an end point. So when we talk about a ray, we can see kind of down here an example. We have a line, but it begins at this particular point. So we'll name this point A, and there would be all these other points along that line. Everything to the right of point A is part of that ray. And so when we name that ray, we use the end point here. So we'll go ahead and say that's the end point. And some other point out here. So we could say point B. And we would call this ray AB. And we would use the line symbol, what we would just put an arrow on that one end. Now this is one where the direction would be different, okay? It would mean something different. If I wanted to talk about this particular array, I always put the endpoint first, okay? If I were headed in the opposite direction, let's say I've got another array, something like this, and I have 2 points on there again. Here's point R, here's point S. If I want to name that array, I have to start with point S because S is the endpoint. So that array, even though the picture shows it pointing to the left, when we name it, we use the endpoint first and then the second point. All right. Examples of things that would not be arrays would be if it had an endpoint on both ends. That would not be an example of array because array is going to extend forever in both directions. We could talk about lines. Would not be, that's going to be considered array, but if I had an arrow on both sides, then it would be a line. Okay. Now one last thing to go along with this is you can have two arrays together that have the same endpoint. So we're going to put down here what are opposite arrays. So opposite arrays are these two arrays that have the common endpoint that form a line. So imagine that we have this line, and I'm going to go ahead and make another one of those. So I've got this line, and right now there's no arrays because there's no endpoint. But let's say, for example, that I put 3 points on here. I've got A, and I've got B, and I've got C. So this entire line could be made up of array BC, which goes to the right, and array BA, which goes to the left. And those two examples, those two arrays, are what we call opposite rays. BA and BC are opposite rays. They form a straight line when we put them together. All right. So I would go ahead and kind of draw a dotted line or circle around these. These on the right, opposite rays, are examples of rays. The non-example would be things like our segment, our line, points. Those are not rays. All right, and our last two terms for today are going to be talking about a segment. So of course, if we cut off one part of the line to get an array, we can cut off the other end, and that's where we'll end up with our segment. So it's a very similar to the array. It's a part of a line. But it's going to have an endpoint on both ends, okay? So this is part of a line made up of two endpoints and all the points between. I don't know if we're going to be able to read this handwriting. Let's see. Part of a line made up of two endpoints and all the points between. Excellent. Right? So segment we could talk about, right? It starts here and it ends there. Segments can be short, they can be long, they can have different directions. What they cannot do is extend forever like a ray would, or extend forever in both directions like a line would. So this particular one has to have an endpoint on both sides to be considered a segment. And a segment, like a line, can be named with its two endpoints. So X, Y. And we just put a line segment over the top. Notice that there's no endpoint. There's no arrows at the end because it ends at X and it ends at Y. So XY is an example We could draw other ones here. RS is a segment. Starting at R, ending at S. Awesome. So we have points, lines, and planes, and we saw that a line could be looked at in parts, rays, and segments. So our very last term that we're going to talk about is, what if you are talking about two things, two geometric figures, like a point, a line, a ray, or a segment, that share some of the same points, okay? And so our last term is not actually a thing, right? So this is not an object. This term is just helping us to understand, what does the word intersection mean, right? What does our term intersection mean, right? So when we talk about intersection, it could be an object, but it's defined by where those two objects or more share common points. Okay, the intersection, this is the shared points between two or more objects. Right, and so when you think about intersection, you may think about two streets. They'll say the intersection of 12th and Prairie, for example. So the intersection is the part of the street that is on 12th Street and the part of the street that is on Prairie. So kind of think about real life. We have this street with kind of that, the line going down the middle. Well, when you have an intersection, you have another street that's passing through that same area. And so you might have Prairie and 12th, like I said, and this intersection is the part that's on both streets, okay? So in geometry, we're talking about where two things meet. So for example, two lines or two rays, they have an intersection right here. So I might say this is A and B, C and D, and right here is point E, okay? And E is the intersection of AB and CD. It's where they meet. Now, of course, non-examples would be things that don't meet. So we could have parallel lines, don't have any intersection. We could also draw parallel planes. You could think about the ceiling of the room that you're in right now and the floor of the room that you're in right now. They do not meet, so there is no intersection. All right, so that's the last of our terms. Let's go ahead and try the second set of our example problems.